Good evening, everyone. My name is Dan Stafford, and I'm an IT instructor at a small college in California. I teach mostly adults. I'm an A plus. I'm Net Plus, MCSA in Windows 10, MCSA in Server 2012, Windows Server 2012, that is. All right, and this lecture slash video is going to be about subnetting in IP version 4. I call it bulletproof your IP version 4 subnetting. This is a method that I've come up with after teaching subnetting multiple times to multiple students over the last 3 years. I kind of had a flash of inspiration and this kind of came to me. So anyways, it works really well. It's pretty rock solid. So I'm going to go ahead and tear into it a little bit. Pardon me if I'm chewing some gum. I have a tendency to yawn a lot when I'm monologuing into the camera. It's not one of my strong suits. So the gum is about the only thing that helps me stop from yawning. So I hope you don't mind. It's in the video. But I'm going to switch over to a screen view so that we can get on to the subnetting part of it. And one of the first things that I find helpful is understanding binary. It's important to use binary for the subnet mask because it makes it much easier to lock in your subnetting in IP version 4. You don't really need to do binary with the IP addresses, just the subnet mask in this method. So I'm going to go ahead and dive into it. I'm going to switch over to my screen, and we'll get a little bit of infinity screen here until I actually pull what I want to show you first. So infinity screen, here it comes. Infinity screen, there you go. Okay, so the first thing I want to talk about is binary, right? Binary has a numbering system, and it's made up of ones and zeros. And I'll get into what those ones and zeros are in a little bit because it's important to understand why we even use binary, and what those ones and zeros are is pretty important in classical computing. So the way you count binary though first is in bytes. All right, we're going to talk about bytes of data, and what a byte is 8 bits. So if you look at this grid here, what I've got here is I've got bytes of data, okay, in binary, and a byte is 8 bits long. And when I'm looking at any byte of data, the value of the bits in that byte of data are accounted for like this. The rightmost bit is worth 1, and then the next bit to the left is worth double that, or 2. The next bit to the left is worth double that again, or 4. The next bit left is double 4, and which is 8. Double 8 is 16. Double 16 is 32. Double 32 is 64. Double 64 is 128. Okay, and that's as far as you go. That's all 8-bit positions. So those are the values of bits in a byte of data in their relative, whatever their position is determines which one they are. Okay, so if we're looking at a byte of data, and the first one on the right is set, and the first bit on the right is set to a 1, which is also known as on. I'll explain that in a little bit here. And all the other bits to the left are set to 0, which is also known as off. All right, that makes that entire byte of data worth 1. You only count the bits that are set to a 1. Okay, so if you look at the second byte of data that I have here, the rightmost bit is off, it's set to a 0. The next bit to the left is on, it's set to a 1. And the value of that position is 2. So that's the only bit that's on, and that's the only bit that counts in the whole byte. So that whole byte is worth 2. Okay. So the next one is, of course, worth 4 because that bit position is worth 4. And that's the only one that's turned on. So the next one down, we actually have 2 bits turned on. We have the ones bit turned on, and we have the 8-bit turned on. And so you just add those two together, 8 plus 1, right? 8 plus 1 gives you 9, okay? We have a little different scenario here. We have the 4's bit turned on, right? The 4-bit is turned on, set to a 1, and the 64-bit is turned on, set to a 1. So that byte of data, all the other bits are off or 0. That byte of data is where 64 plus 4, or 68. And you can see where this is going. You just add up the bits that are turned on. Now, one thing I want to point out is if all the bits were turned on, you add 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. If all the bits were set to a 1, all 8 of them. And that adds up to 255. This is why 255 is the maximum number that you can have in any octet of an IP address. Because what's an octet? It's really a byte of data, all right? An octet is a byte of data. Octo in Latin means 8. It's like ocho in Spanish. It means 8, right? So it's referring to 8 bits. An octet just means a set of 8, right? And it's 8 bits. Now, as far as what ones and zeros are, okay, in binary code, a 1 is literally on, electrically on, and a 0 is literally electrically off. If I were to get a microscopic voltmeter and look in a memory address that had a 1 in it, I would be able to find voltage there. And if I were to look into a memory address with my little microscopic nanovoltmeter and find a 0, I would not find any voltage there. I would not get anything because literally a 1 is electrically on and a 0 is electrically off. Okay, this is how computers turn electricity into information. And if you take a look at almost any power symbol since like about 1983 or later, I'm not sure exactly when this came out, but this symbol for power came out somewhere in the early 80s, or if I remember correctly. And if you take a look at the power symbol, right, this is the power button on the corner of a monitor, a video monitor, and it's really a 1 and a 0. And what does that button do? It turns it on and it turns it off. That's why the power button is binary. Literally, the bi part in there means 2 in Latin. And binary means there's 2 possible conditions or 2 possible states. There's either the possible condition or state of on or the possible condition or state of off. So if you think about it, and even your electric wall switch is a binary device. It either can be on or it can be off. All right, and this is why the power symbol, the universal symbol for a power button, is a 1 and a 0, because in binary 1 is on and 0 is off. All right, if you look around, you're going to see those everywhere now that it's been pointed out. I noticed this right when that symbol came out because I was happened to be learning binary about the same time. So again, 1 is on, 0 is off, and that's binary for you. Now, I want to get in how to relate this to subnetting. So I'm going to switch over to Windows Notepad here, and we're going to get into it. And I've got some general guidelines or rules up here at the top, but I don't want to focus on those just yet. But what I do have up here at the very top is the value of bits in a byte of data. And this is why I really want to make sure everyone knows how to write this out, because you really, if you're going to subnet, this is your ruler right here once you learn this method. Okay, so let's start with the kind of hard one first. Now let's do some class A subnetting. All right, so we're going to go with a network of 10.0.0.0, which is a class A address. And there's a way in binary in the subnet, by the way, to tell the value or the how the classes end. And once you see it in binary, it really makes a lot of sense. but we'll talk about that in a bit towards the end. Right now, I want to focus on this. So, default subnet mask for binary is /8 in CIDR notation. CIDR, CEDAR. Oops, little typo there. Okay, CIDR, CEDAR, whatever. /8 is default. So, and what that /8 means is if you're looking at the subnet mask in binary, right? If you look at the subnet mask in binary, the first octet, which is the octet furthest to the left, is all ones. Okay, because and then all the other octets are ones. Okay, so again, classful addressing here, right? Class A address, default subnet mask is /8. And when you look at it in binary, what that slash number is telling you, what that /8 is saying, is that your subnet mask has 8 ones in it. And I'm going to tell you right now, wherever that last one is in a subnet mask, everything to the right of that is going to be zeros. Everything to the left of that is going to be ones. You will never see a subnet mask in binary that has a 0 over here after that last one. This is not about IP addresses. This is only about the subnet mask. All right. So just thinking about the subnet mask itself. Okay. So what does this subnet mask do? Well, it's kind of like a secret decoder ring for IP addresses. What the subnet mask does is it tells all the equipment on the network, hey, when I look at an IP address, if the subnet mask has a 1 in that position, then that bit in any IP address going around on my network is part of the network part of the address. That's the network portion of the address. So any IP address floating around on this network is going to use those first 8 bits with this subnet mask as set as the network portion of the address, and then any bits in the subnet mask that are set 0, those same bits in any IP address are going to be available for host addresses on that network, right? So the ones identify the network and the zeros identify the host addresses on that network, including the network address itself and the broadcast address, right? So that's what the subnet mask does. It tells all the equipment how to interpret the IP addresses that it's seeing, which part's the network and which part's the host. Well, the subnet has a 1 in that position, so that position on the IP addresses is network, or the subnet has a 0 in that position in the IP addresses is host, okay, on that network. Okay, so now we have a class 8 or a /8, sorry, in CIDR, which means we have 8 ones in the subnet mask, right? If I had a /9, I would have to add another 1 over here, and then my subnet mask would look like this, right? Because if I have a 1 here, how much is that worth? 128, right? Because what are we looking at here? We're looking at 1 byte of data, 8 bits, right? I have an extra 0 in that one, right? 8 bits, 8 bits, 8 bits. Octet 4, Octet 3, Octet 2, Octet 1, and they're 8 bits each. Okay, so when I look at a byte, at the value of a byte, that one's worth 128, going by my ruler here, and that means this is everything in the ruler adds up to 255. So my first octet is 255 for the subnet mask. And oops, sorry, that was supposed to change to a /9, which would be why we have 9 ones. All right. If I had a /10, that would mean my subnet mask would have 10 ones. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? All that is saying is how many ones do I have in my subnet mask? That's all that means. That's it. How many ones are in the subnet mask? And then, of course, I'd have 128 plus 64, which gives me 192. Okay. So we're going to go back to 0 here, though, for a minute. And we're going to go back to /8. And we're going to get rid of everything after those 8 ones for a minute. And then we're going to set up ourselves with a problem. Let's say we need, let's say 50 networks. We need to chop that up. We're going to take that network that we were given, that 10.0.0.0 network with a /8 subnet. We need to chop that up into 50 smaller networks. Okay, let's say that's our problem for right now. And I'm going to focus on the network side of this for a while here because the understanding how to subnet for networks first makes it a little easier when you try to turn around and subnet for how many hosts you want, right? So we're going to focus on the number of networks first. So I want 50 networks. And I don't care how many hosts right now. I'm focused on how many networks, right? The hosts are going to be a function of the way those networks are structured, and it's all math, so they're going to be what they're going to be. So right now we're just going to focus on those 50 networks. We need to get 50 networks. And my subnet number 1, it's always going to start with the address that I was given, right? In a situation like this. So in order to keep everything easily readable and nice and even so you can see patterns in the numbers, I'm going to put in the zeros that are omitted in the decimal representation of these subnet address ranges. Okay, so now I have 10.0.0.0/8, which means I have 8 ones in my subnet mask. And before I do anything, I already have one network. I have the 10.0.0.0 network. I have a network right now. I don't have to do a single thing to have one network. It was already given to me, that 10.0.0.0. So what we're going to do is we're going to add ones to the subnet mask one at a time. All right. And every time I add another one to the subnet mask, it doubles the number of networks. Now, before I add a single one, I already have one network. So as soon as I add another one, it's going to double it and give me 2 networks. I add another one, it's going to double it again. I have 4 networks. Add another one, 8 networks. Add another one, 16 networks. Add another one, 32 networks. Add another one, 64 networks. Oh, I needed 50. 32 wasn't enough, but 64 is, right? I have no in between. There is no way to get to exactly 50. So I met or exceeded the requirement for 50 networks, right? So again, how I got there, I add ones to the subnet mask. And before I do a single thing, I already have one network. So as soon as I add a one, I have two networks. Add another one, I double it again. 4 networks, 8 networks, 16 networks, 32 networks, 64 networks. Oh, met my 50 network requirement. And let's see here. What do I need? I need a couple of zeros. And then everything else is going to be zeros. Okay. So this is going to be my final subnet mask in binary. In decimal, what's that? 255 minus 3, it's going to be 252. All right, so if all of them are turned on, it adds up to 255. These two that are set to zeros are worth 1 and 2. 1 plus 2 is 3. 255 minus 3, all right, gives me 252. Okay, so this is my new subnet mask in decimal. All right, 255.252.0.0. All right, now anything in any one of these networks, all of these bits are going to be the network portion of the IP addresses, and all of these bits are going to be the host portion of the IP addresses. Okay. Now, what we want to look at is where is the last one in the binary subnet. All right, that's our octet of interest. And here's how we're going to use that. The last one in this particular subnet is in the second octet, right? So our second octet is where we're going to have our action. All right, this is where all the action is going to happen. All right, and how much is that last one worth in a byte of data, right? So it's the third position left, that's worth 4. That means I must use 4 numbers per subnet range in the second octet, right? The last one is in the second octet. Its value in a byte is 4. I get 4 numbers in the second octet. 0 happens to be one number, so I get 3 more. Okay, and for a little bit more of a visual representation, let's do this. 0, 1, comma, 2, comma, 3. That is 4 different numbers, is it not? All right, 0, 1, 2, 3. That's 4 numbers. Okay, this is why in my second octet I have 0 through 3. Okay, now for my next subnet here, subnet range 2, I cannot use any of these same numbers in the second octet. All right, so my second octet must increment above 3. It has to go to 4 at the beginning of the range. Now, in order for this octet to go from 3 to 4, both of the octets to the right of it must go all the way to 255. Right? These octets are like kind of like a car odometer. You can think of 255 as like 9 on a car odometer, right? When this octet hits 255, this octet goes from 0 to 1. It hits 255 over here again. This one goes from 1 to 2. Hits 255 again. This one goes from 2 to 3, and so forth, all the way up until they're both at 255. And when both of these are at 255, this octet goes from 3 to 4. All right, that's how these octets increment. And of course, when this octet increments by 1, the very next thing is these two go back all the way to 0 and then start counting up again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 through 255. 1, 0 through 255, 2, 0 through 255, 3, 0 through 255, 4, all the way up until 255, 255, and then this one would go up to 5, back to 0 again on everything. That's how that works. Okay, so now what do I got? My last one is in the second octet. It's worth 4. I get 4 numbers in the second octet. And that's going to give me 4, 5, 6, 7, right? All right, I have to fill both of those two octets all the way up before I can get subnet 3, because it's got to be a different number than anything I use in the previous one. Oh, there we go, much nicer. And then 8, 9, 10, 11. Okay. I also want you to notice something else that's going on here as this plays out. There's a little bit of a pattern going on in the numbers. If you take a look at the second octet on the left-hand side, you'll notice all of these are even numbers. And that's going to keep happening if I'm correct, right? If I do this correctly. Everything on the right-hand side, which is the broadcast address of each of these subnets, by the way, is all odd numbers, right? So if I'm doing my math and I throw an even number on this side somewhere, I know, oops, I just goofed on my math, right? Or if I come off with an odd number over here on this side, oops, I just goofed up my math because look, it's falling all even. And what you want to do is do your first few address ranges and then kind of watch for the pattern and the numbers like that. And it'll tell you. That's another way to kind of check up on your math and make sure that you didn't goof on it. Okay, I could roll this out all day long, all the way up to 50 networks, but that'll take all evening. That's a lot to do, but be aware that on the left side you have the address of the network for each subnet now. All right, this is the address of the network, so this cannot be assigned to a host. All right, and this is the address of, or the broadcast address for that subnet, right? These on the right hand side, these are the broadcasts. So on this first one here, I can use anything from 10.0.0.1 through 10.3.0. Sorry, dot 255.254. 10.3.255.254 for host. So 0.1 through 0.250, or sorry, 255.254 are available for hosts. So there's an awful lot of hosts on these networks. Okay, so this is an example of using this method for a /8 subnet or class A. All right. Now, let's take the same example and apply it to a class B subnet. All right. And what I'll do is I'll get rid of this. And We'll subnet out 3 or 4. Let's go through 4 of them. And we're going to chop up class 8 into 50 networks, and sorry, class B into 50 networks. So let's do like 132.16.0.0 and a /16 to start. Okay, and what does that 16 mean? That means I have 16 ones. That /16 means I have 16 ones in my subnet. That gives me a decimal subnet of 255.255.0.0. And to get to 50 networks, I'm going to have to add ones. All right, I have one network with 16 ones in there. All right, /16. So as soon as I add a 1 to the subnet mask, I double it. That gives me 2 networks, 4 networks, 8 networks, 16 networks, 32 networks, 64 networks. Oh, okay. 64 networks. Just to change things up, let's change this to 30 networks. I need 30 networks. So let's do that again. We're going to change things up just a little bit. Okay, so now I'm back to 16 ones and 1 network. And all right, 17 ones gives me 2 networks, 18 ones gives me 4 networks, 8 networks, 16 networks, 32 networks. Oh, met my 30 network requirement, right? And what I got there? I need 3 zeros. All right, and that gives me a subnet mask of, all right, 190, 128, 192, 224, 240, 248. So I believe I have a 248 there. Okay. Because 128 plus 64 plus 32 plus 16 plus 8, or 255 minus 7, right? 255 minus 7, or 128 plus 64 plus 32 plus 16 plus 8, right? Okay. Now we're going to start with the address we were given on the first subnet. Okay. And we'll put it there, but I'm also going to add in any omitted zeros in the decimal notation for this address range to keep it nice and even and easy to read. All right, so my subnet 1, now I'm going to take a look at where my last one is. That's my octet of interest. In this case, my last one is in the 3rd octet. So my octet of interest is going to be the 3rd octet, right? And that last one in this case is worth 8. So I must use 8 numbers in the 3rd octet per subnet range, right? I must use 8 numbers in the 3rd octet per subnet range because the last one is in the 3rd octet, and in its byte of data it has a value of 8 because it's in the 8th bit position in a byte of data, right? So 1, 2, 3, 4, 1, 2, 3, 4. That value is 8. I get 8 numbers in the third octet. Okay, 0 being one of the numbers, I get 132.016.007, right? 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. That's 8 numbers. And then, since I'm going to have to use the next highest number in the next address range, I must fill up the fourth octet for the third octet to increment. All right, so I'm going to go ahead and copy that so I don't have to repeat typing that every time. And here we go. 8, 9, through 15. Okay. And 016. 16 plus 7. Give me 23. And 23 plus 7, or sorry, 24 plus 7, that is going to be 31. All right. And as you can see in each subnet address range, I got 8 different numbers total. 0 through 7 is 8 numbers. 8 through 15 is 8 different numbers. 16 through 23 is 8 different numbers. 24 through 31 is 8 different numbers. In the second octet, because that's where the last one is, and because the last one is worth 8 in a byte, I have 8 numbers in the third octet of each address range for each subnet. This is the address of the subnet over here. This is the broadcast address for the subnet, and I can use anything in between those two for host addresses. And if you look, again, my left side third octet is going to be all even numbers, and my left side or right side third octet is going to be all odd numbers here. So if I throw an even number over on the right side, I know I goofed. If I throw an odd number on the left side, I know I goofed. All right. And that is how you do a class B. And just so it doesn't throw you, we'll do a class C as well. I wanted to do, actually, let's do a class B that gets us, yeah, this one kind of gets tricky, so I want to do an example of this. So hang on, let me figure this out real quick, what I'm aiming for here. So let's say I wanted 250 networks. Let's say I wanted 250 networks. And I started with the /16. And I want 250 networks, right? 250 networks. All right. So I have one network to begin with. Add a 1, 2 networks, 4 networks, 8 networks, 16 networks, 32 networks, 64 networks, 128 networks, 256 networks. Oh, 256, that met my 250 requirement. And there we go. I just filled that octet up, right? And my last octet is going to be all zeros. Okay. So now I have a subnet mask of, ooh, it looks like a default subnet mask for class C. 255, 255, 255, and 0. Okay. So my first address range is going to be what I was given, 132.16, 0, and 0. And now we're going to take a look. Where's that last one? Oh, it's still in the third octet. The last one is still in the third octet. But how much is it worth in a byte? 1. It's worth a value of 1 in a byte. So I only get to use one number in the third octet for each address range. So okay, 0. I only get one number per address range. All right, that's it, 0. I got my one number. Right, one number per address range in the third octet, right? Because that last one is in the third octet and it's in the byte position for a value of 1. I get one number in the third octet. That's it, only one number to use. And that makes it pretty easy, actually, if you don't let it ruffle you there. All right, last one is in the third octet. It's worth 1 in a byte. I get one number in the third octet per address range, so 0, that's one number. 1, that's one number. 2, that's one number, right? And this is how it rolls out. And notice again, here, we can't count on that pattern of odds and evens. It just doesn't work out that way with the math, but it's also pretty simple. If I have another number in the same address range, oops, I goofed, right? Because I only get one number in that address range in my third octet. Okay, and that's how you handle that. And this is how you bulletproof subnetting. Now, I want to talk about how to handle hosts. Okay, let's say I wanted to subnet for let's say I wanted 512 hosts per network. 512 hosts per network. Well, now I'm going to look at it the other way around. I'm going to look at how many zeros do I have, because the zeros are the hosts, right? So 1 0, that only gives me 2 possible addresses. That's it. I only get two addresses with that. And since one of them has to be the address of the network and the other one has to be the broadcast address, I would not have any addresses for hosts on here. So however many it is, I have to always subtract two because I have to save one for the broadcast and one for the address of the network. All right, but if I have 10, that's two addresses, four addresses, eight addresses, 16 addresses, 32 addresses, 64 addresses, 128 addresses, 256 addresses, and 512 addresses. Oops, I meant to set that to 510. Okay, so I just made it right there. With that many zeros, I have 2, 4, 8, 16, 32, 64, 128, 256, 512. Oh, I have to put a zero there. Okay. Now, now I just look at where that last one is again. Oh, it's in the third octet and it's worth 2. So now I have to use two numbers in my third octet. 0 and 1, that's 2. 2, 3, that's two numbers, right? Because my last one is here now in the third octet, and it's worth 2. And 4, 5, 6, 7, and that's how you would work hosts. You work with the number of zeros, but you take away two addresses for the network and the broadcast. Okay, this is why I like to focus on the number of networks. I prefer to work that way because then I just add ones to the to the CIDR notation. But if you need to solve for hosts, you start adding zeros until you've got two more or more than those two that you need for the subnet address and for the broadcast. So again, 2, 4, 8, 16, 32, 64, 128, 256, 512 minus 2 for the network and the subnet mat or the broadcast. That gives me 510. That's how I got there. So it's also, you can see really quickly that it's kind of important to know your doubling, right? So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096. Let's see, 8192 is it? I believe. Let me bust out the calculator. I usually have this memorized, but yeah, it is 8192, 16384, 32768, 65536, and I believe it's 121 something. 131.072. But I pretty much have that number pattern memorized up to 65536. And if you remember that pattern of doubling numbers like that, if you memorize that, that is going to help you a lot with subnetting. Um, if you know it cold up to there, you'll probably be fine. If I could memorize that last one, I really need to get that one down, and that's about as far as you really need to go. But if you can memorize this pattern of numbers, that's really going to be helpful. And memorize this pattern of numbers for sure, which is really just this. Okay. And that's how you bulletproof your subnetting. So on that note, I am going to switch back to the infinity screen and then switch back to the camera. And I'm going to say that was a nice long lecture. I didn't yawn once. Thank you, chewing gum. And everyone, I hope this helps with your subnetting. And I will catch you on another time around. And hopefully this is helpful to everyone. Thank you.